Hello, Richmond San Pablo Steering Committee members and members of the public. I'm Joe Hicken. I'm with Aclima, and joining me on this remote presentation is our Chief Scientist, Dr. Melissa London.
Hello. Hello.
And our Head of Product, Adam Borelli.
Hello.
We were very much looking forward to doing this presentation in person. The in-person experience, it tends to be much richer, but in the absence of being able to meet with you all in person, we are recording a remote presentation. And the advantage of that is you'll be able to go back and rewind if there's something that we said that you'd like to revisit. You'll be able to do that. On a personal note, we hope that your friends and family are safe and healthy during this shelter-in-place period of time. But without further ado, we're going to jump into the presentation before you. We're going to provide you kind of a brief orientation of the science behind what it is that Aclima does, an orientation to how it was that Aclima collected the data, and then we will be showing you an actual tool that you can experience right now. You can actually skip this video entirely and go to insights.aclima.io/Richmond-San-Pablo, where you can access the tool right now. You don't need to watch this video to interact with this interactive report and see what Aclima saw when we measured air quality for a quarter from August until September of 2019. Sorry, August until October of 2019. But with that, if you'd like to know more about the science, how it was that we collected the data, and a kind of a brief tutorial of how to interact with the report, please watch the rest of this video. And at the end, we'll say this, but please send us any comments or questions you have. We'd love to hear from you. The email that I'm about to give you is operated by real people. So if you email us, we'll respond back to you. You can email us at hello@aclima.io, ACLIMA.io. And one last comment, we're recording this video in early April. Aclima is constantly updating its software experiences, and so if you're seeing this in an archive many months from April of 2020 from now, your experience might be slightly different or very different depending on the improvements that we've made in an intervening period of time. So thank you so much. So I am going to turn it over to Dr. London to provide the presentation.
Great. Thank you, Joe. So just move forward to restate the agenda. We're going to go through the science of how we measured and analyzed the hyperlocal air pollution, what we did in the Richmond San Pablo area, and some features of interest, if you will, that we found when we were looking at the map that will help you give you a feel for perhaps how to think about the data yourselves. And then we're going to wrap up with an Insights demo. Adam will demo the live version of the Insights report tool also on this recording. So to sort of quickly dive into the science, so there's a critical gap in sort of air pollution data, if you will. There's limited coverage of regulatory measurements, which are the measurements that we rely on right now to understand what's happening in the San Francisco Bay Area, in our city. There are, shown here, for instance, on the San Francisco Peninsula, there's just this one data point up in San Francisco, and then there's no other measurement. There's no other measurement for several miles to the south and to the north. And so that really doesn't give you much feel. It's a low resolution, and it certainly doesn't tell you what's happening in your neighborhood or in your city or on your block. Aclima's platform, what we've been doing is building a device, a sensor-based device with best-in-class air quality that we put into our cars as a mobile platform. We do end-to-end network management, which means that we are managing the cars and the drivers. We're giving them the routes and how to drive, and making sure that we drive in a way that's statistically representative, which I'll get into more detail later. Aclima also does the data management and analytics. We have the data stream in, and we can do synthesis and build tools, as you see with the data. And then the software tools people can use, and then eventually, as we continue to work with this, integrate other data sets, land use, for instance, or others that can help make this data actionable. So what we do is, you see here, we have one of our Aclima sampling cars, and we're driving down every street in a particular area. We drive each street multiple times. We drive each street, to be representative, we drive each street 20 times. And so basically, we continue to drive down the street equally dispersed over time of day and day of year, so that we have representative sampling across sort of all conditions in the atmosphere. That's how we collected the data that you're going to see on our maps. If you move to the next slide, Joe. So this repeats what Joe gave in terms of the website, aclimainsights.io, Richmond San Pablo. You can go there right now if you would like, and look at the website as we go through the rest of the presentation here. So we mapped for 3 months, from August 1st through October 31st, 2019, covering all of the 7 focus areas identified by the committee. We used 5 vehicles to do this mapping over the 3 months, and 3 of the operators we hired locally from the Richmond San Pablo community, which we're really excited about, being able to try to support the local community and have the community support the mapping. Sorry, I'm just getting set up myself here. So we mapped for 92 days. We covered 42 square miles, and we drove about 26,000 square miles. On this map here, you see the area colored by the number of times that we drove on each segment. A segment is about 100-meter length of road. So we divide our measurements up into these approximately 100-meter segments, and then we take the data in each segment and average together. So each one of these passes through one of those segments, and you can see that with a significant number, majority of the segments we drove more than 20 times, and there are some segments we really sampled quite a bit, up to 150 to 200 times. We measured, in terms of what pollutants we've measured, we measured carbon dioxide and carbon monoxide, nitric oxide and nitrogen dioxide, ozone, and PM2.5. So each one of the cars was measuring all of these 6 parameters over the entire study. What we found here, you can see the map of the area as you will see in Insights. This is a map of PM2.5, average PM2.5 concentrations from the August to October timeframe. You can see a color scale in the lower left-hand side of the figure, showing that the darker purple colors, the darker purple is closer to 0 PM concentration, and that sort of light green to yellow color is 25 micrograms per cubic meter. And so you can see some of the color variation across the map, showing the concentration variation throughout the city. And then we looked at the data and sort of highlighted a few areas just to show sort of what features the combined data sets can show. And so, for instance, in the Point Richmond area and the Hilltop Green area, those were both areas that had lower level of pollution overall when compared to the rest of the city. And we indicated sort of in some area lower concentrations of PM2.5, CO, CO2, NO2 up in Hilltop Green. Compared with this region in the Iron Triangle, where we saw higher, on average, measurements of NO2 in that particular region of town. In that area right near where Carlson Boulevard and 580 and the train tracks all kind of align, we saw elevated levels of PM2.5 and NO2 combined. And you can see that sort of oblong shape. Along the 23rd Street corridor, we saw high levels of 3 pollutants, NO2, CO, and CO2, that all indicate high traffic. These are emissions from automobiles and trucks. And so the concentrations that we saw along 23rd Street corridor were similar to those that if we did a similar sort of average along, say, Cutting Boulevard or San Pablo Boulevard, similar levels, which just indicates that indeed the 23rd Street corridor is a street that is traveled, does see a lot of traffic, especially compared to other major roads in the area. If you move to the next slide. These are the results, the average that we measured over the entire time period for the entire area there from, the ocean up to San Pablo. So we measured 9.1 micrograms per cubic meter of PM2.5. That ranges, the range we saw at the lower end was 6.6 and then the higher end was 11.8. So that's how to read this particular graph or this particular table. So for ozone, 23.1 ppb parts per billion. The low end was 20, the high end was 26.5, a pretty narrow range. Nitric oxide on average was below 10 ppb, 10 ppb parts per billion, which was the lower end of what our sensors are able to detect. Nitrogen dioxide, 8.4 parts per billion, ranging from 3.6 to 14.4. Carbon monoxide, 0.39 ppm. You can see the range there, 0.29 to 0.58. And carbon dioxide, the average was 4.29 parts per million. Now, it's important. These are numbers, that we can calculate from the data, but what kind of perspective can we put them in with respect to sort of impacts on health? What are these concerning levels? Where does it fall within sort of regulatory standards? And so those regulatory standards are basically established to sort of basically based on health outcomes. They give us a feel for what does this data mean to me, what is considered unhealthy versus healthy. So you can look at there are both California and national standards for ozone and PM2.5, carbon monoxide, nitrogen dioxide. And so here you can see some of those levels and note them down and compare with what you'll see in the tool as well as the averages that I showed. But I should say a caveat, you'll see here that the averaging time for some of these pollutants is 8 hours or 1 hour. And that the standard is that the ozone only exceeded that standard 1 or 2 times a year. And so it's a different way of thinking about concentrations and their health effect. It's really focused on what's the longer term action over 1 or 2 or 3 years, while what we have done is measured the concentrations on average over this 3-month time period. So there certainly is some comparison that can be there, but our standards, these standards were defined around the traditional technology, the regulatory technology, the sort of regulatory site. The types of measurements that Aclima does right now, the block-by-block measurements, weren't possible when regulatory standards were defined, several decades ago. Standards track regional averages, and attainment is based, to the standards is based on these regional averages. And so the network does a great job of really getting a snapshot of the Bay Area or the Southern Bay or the Northern Bay and how those parts of the whole area are tracking with respect to air pollution, the Livermore Valley, southern San Jose. And so, and these measurements have allowed us to make progress, certainly on reducing air pollution around the U.S., but regional averages don't capture the hyperlocal experience. You can see with the Richmond map that we showed that there were variations within, just a few blocks, Iron Triangle neighborhood versus sort of Point Richmond versus other neighborhoods. And so that's what's really exciting about the type of mapping that we do, and that's why we think it brings a lot of value to the type of work and decisions that you're thinking about. And so with that, I think we're going to move to a demo of the tool. And Adam will sort of build on what we've already been talking about and show you how to explore the tool on your own.
Thanks, Dr. London. And thank you all again for joining us from your home or your phone or wherever you may be at the moment. We appreciate you making the time. If you do have a phone in front of you and you're not on it right now, suggest going to insights.aclima.io/Richmond-San-Pablo, and you can join along in this demo with me. So, I want to take a step back and talk a little about the product itself, this digital report itself, and then we can go into kind of how to use it. So first of all, we really designed this with a mobile-first mindset, thinking about time We want to make sure that it works really, really well on people's phones. So as you can see, this entire mobile report or digital report is all works really well on your phone. Secondly, people care about locations. They care about their community. They care about specific places in their community. So we made it searchable by address. And I'll show you how that works a little bit later, but you can see down below the ability to enter an address and get some data about that address. And then we also wanted to put it on the map interface because we all understand our communities based on what is around, based on what's around them. So we wanted to make it this familiar interface where you get a chance to understand the location and the streets that are around it. And finally, we want to make sure it's accessible to people. And so we made sure that it's translatable into English as well as Spanish. So if your first language or preferable language is Spanish, you can just click on this little square in the top right and translate it, and you can see that we translate it into Spanish as well. So I'm going to translate it back to English so folks can consume it that way if that's their preference, and if you prefer to use it in read it in Spanish, feel free to do that and follow along as well. So with that, I'm going to assume that folks haven't really used this before and walk you through sort of the high-level functionality, and then we can actually get into using the app itself. So let's take a stroll through Insights, our digital report, and let's go down to a little summary about what we did. This is a brief summary of kind of our time from August through October 2019, the sampling we did, the data we collected, how this fits into the broader context of AB 617, and other efforts that are happening locally in Richmond, San Pablo. We also have a link here to our methodology. So if you're interested in learning about the scientific rigor that goes behind this, and maybe you followed what Dr. London said, but you want to have something to reference for others, you can click on this link here, pull up this modal, and read more about it. This is important information. This is also really complicated information, so we like to distill it for everyone to be able to understand kind of our takeaways from our time collecting this data in Richmond, San Pablo. And so, as Dr. Lennon showed us before, we highlight different areas and the kind of takeaways from those different parts of the community here. Now, on the map, I want to orient everyone here. We have a color scale. It goes from dark purple on the low end and bright green, kind of lime green on the higher end. And so the way to look at this map is that your sort of darker purple colors are your lower areas of concentration, and your really bright green colors are the areas of higher concentration. So keep that in mind when you're looking at all the different maps that we surface within the product. And then, of course, as I mentioned before, you can do an address search and look things up, which we'll do in just a moment. You also, we want to make sure that not only is this information available, but that it's actionable. And so we have some next steps that we created in partnership with the Richmond San Pablo Steering Committee that folks can do there. Things that you can do right now, things that you can do in the next week, and things that you can do over the longer term to have an impact on public health and climate in your own community. So let's just go back up to the map here, and love to look up an address. You'll see we have the Richmond Arts Center here, and you can see that the measurement was for PM 2.5 was 9, and then that's about higher than 52% of the measured area. So it's about average in terms of what we saw throughout the region. And then you can also see how that compares to other areas that are nearby. So Richmond Memorial Auditorium, a little bit higher at 10, Richmond City Hall, higher at 12, and then Richmond Public Library, a little bit higher at 10. And then if you want to share this information, you can share it through the different social platforms, Facebook, Twitter, and Instagram. You also copy and share the URL directly. And we know that PM 2.5 isn't all that matters when it comes to public health, so we provide more information about the different pollutants that we measure down below. You can see PM, you can scroll here, just tap here to the right on the arrow, on the little arrow. You can see ozone, nitrogen oxide, carbon monoxide, carbon dioxide, nitrogen dioxide. And so you have a sense of kind of how that location compares, not just in terms of PM 2.5, but also the other pollutants and greenhouse gases that we measured here. I'll take a step back and actually type in another address that we thought was kind of interesting, 601 Spring Street. Okay. And then it takes us there in the map. Okay. So you can see it's a brighter green color, closer to the lime green on the far end of the spectrum, but not quite at the far end. And we saw a pretty, relative to other areas, 21 micrograms per meter cubed, higher than most other areas. And you can see that represented here in this information. 21 is higher than 99% of the measured area during the time period. So, again, we help you contextualize it within the area that we measured in Richmond San Pablo over that period of time, and then how it compares to other nearby places. And you can type in any place. You can type in your home, you can type in movie theaters, you can type in places of worship, places that matter to you. You really want to make sure that you're able to find that information within the app. And have tried to make it really understandable so that's very accessible within the map interface. So with that, I've done my job of hopefully my job of helping explain how it works, and I'm excited for you to use it and share the feedback with us so we can make this better for you over the course of time. Appreciate you taking the time, and with that, I'll turn it back over to Joe.
Great. Thank you so much, Adam, for walking us through the tool, and thank you, Dr. London, for giving a brief overview of the science behind how it was that we collected that data. Just want to let everyone know, again, please send us an email at hello@aclima.io if you have any questions or comments. We'd love to hear from you, and we mean that sincerely. And also wanted to make sure that everyone knows that this mapping campaign, this interactive tool, while representative of conditions from April, those 3 months, from August until October, Aclima's fleet of vehicles is actually mapping the entirety of Contra Costa County as well as the rest of the entire Bay Area for the next 2 years. And so we'll be able to provide some ongoing information with regards to ambient air quality on a block-by-block basis from not only this tool but into the future as well. So with that, thank you all for your time, and thank you, Adam and Melissa, for your time as well. And we hope to be in touch and in front of you again in short order. But for now, be healthy and be safe. Thank you so much.